Hey, everybody.
I was worried that my sound wasn't working.
Nope. I think your sound is working okay.
Can you hear me? Okay, there we go.
Yep.
Sorry, I couldn't get my mic working this whole time. All right, so let's get started. I think Herman, we had you first on the agenda.
Yes. Can you all hear me?
Yes,
Yeah,
loud and
cool.
clear.
I'm all the way from the Netherlands, Europe. So it's evening at my place. I didn't know about this, or did know about the SIG, but I didn't know what you were working on before KubeCon. So that's a great way to get to know people. And what I scheduled was MC Robot, which is the way we do some synchronization between clusters. And I'm specifically working for Q42, but that's not the point. The point is that we are working for a client, which is Philips Hue. So the IoT cloud platform that has bridges and lights in your home, which you can control via Google and Alexa, that is actually built using Kubernetes. So I'm the tech lead of that project. So I created MC Robot to synchronize between clusters. Specifically, you have a bridge in your home, and you have a mobile phone, which is needs to connect to this bridge. But it can also be that you just went out of the house and you want to enable the lights while not at home, or that you do that via Alexa. But then it can be that Alexa is in a different cluster, or connects to a different cluster than the bridge has connected to, which uses a WebSocket connection. So it has a fixed destination. And the HTTP request can be proxied to any cluster. To do that, we need to have some inter-cluster communication. And we use MC Robot for that. So, and don't know if you looked at the repository yet. You can go ahead and open it. It's very minimal. I can even share it maybe here. Oh,
yeah, please do.
Oh.
Let me know if it lets you.
Host disabled attendee screen sharing.
You should now be able to share.
Cool. And then I don't yet see the. Oh, I need to somehow. Okay. Well, then share the whole screen. Oh no, privacy settings. Oh, damn it. Well, never mind. I think I will do it out, because otherwise that will take a while. So if you go to the repository, you see a nice picture of a robot, which is the MC. And MC is multi-cluster, of course. What it does is it uses PubSub, Google Cloud PubSub, but it can be any means of PubSub. So it can also connect to SQS or something. We use the Golang project Go Cloud Dev, which can actually connect to any PubSub storage. And it will publish all the nodes in the cluster together with a list of node port services, basically. So I can also share in the in the chat a bit of how that works. So at this location, you see that we do a publish of the local state. Then I need to open it myself too. And that state is filled based on the just reading the Kubernetes API via watch operation. There's also a subscription to the remote cluster states from other clusters, which is happening just above. And then it will build basically services for each of the clusters.
Is there any visual you could have to orient some of this, Herman?
Let me think about that. If I have a visual.
If you don't have one ready, don't sweat it. It just might help for the recording.
Yeah, so I do, but it's. Let me. Yeah, well, I do have a picture, but how do you get it somewhere? I'm curious. No, that's a private link. No, unfortunately not. If I would be able to, can I drag something to the chat? Yes, I can. No, it copies the link. Okay, so too bad. Basically, we have two clusters, and they all have same service. So it's basically the destination of all the HTTP requests, and there is a component which is sitting before that, which is an Nginx. This Nginx gets a request, determines if it needs to go to the current cluster or a different cluster. It does so via the out request directive. So there's an out request thing you can do in Nginx, make a breakout to a different service. This can return an 200 OK or a 401. If it returns a 401, then the request is aborted. But if you return a 200, then you have the possibility to add also headers to the request. So we use that to determine the upstream. And there are multiple upstreams in Nginx configured, one for each target cluster.
So when you import these services, are you importing a separate service when you create these services for the multi-cluster services? Are they a separate service for each of the node port services that are exposed, or do you create a service that spans multiple clusters?
No, we create one service per cluster. So the name of the cluster actually is, and what maybe this helps. I have a gist, GitHub gist, which I prepared for this meeting. It contains some private information. So yeah, well, it's not really too private. It's a testing environment, but don't post it on Twitter or something. This is the service sync is the custom resource that we define in MC Robot. So if you look at it, you see that there is a selector, which uses a label selector, matches certain services by the label app.
We had a question from Tim in chat. If this is an alternative to the multi-cluster service model or designed to work with it. And from my understanding, the multi-cluster service model we've been talking about is new to you from KubeCon. So this is an alternative that you've been pursuing.
Yeah. So I'm just explaining this what we built, and probably you will be able to provide some input to how we could replace this or how we could learn from both from each other. And of course, this is a very custom built solution. Your solution will be way better and more generic. And I'm very I would like to migrate to open source / community built approach. But maybe it looks a little bit the same. So let's take a look. And if you go to the gist and you go to line 33, you see a status, which is of course not in the CRD resource in the repository of MC Robot, but it shows what is actually saved. So the way it works is it first updates this resource based on the publish of all the other clusters, building a list of clusters and a list of services in those clusters with endpoints and port definitions. And once it has done that, the status is stored in that object. So it then can ensure that the services are created according to this object. So it's a two-step approach to ensure that if the pub/sub goes down, that this is no problem. And for each of those clusters, services are created, which you can see below where I got one of the services from in the second file. There's a service which is a cluster IP service targeting endpoints which are below, and those endpoints also outputted in the gist. Those reference the hosts of the other cluster directly via the node port, because they are in the same VPC network. So that is the constraint that we were working with, that they are indeed in the same VPC network. We had a short period with Philips Hue where we migrated from a non-VPC network cluster to a VPC network cluster. And there we needed to actually span the internet, because legacy networking in Google, you cannot pair that to VPC networking in some way. So that we did using the public internet, but it was a different solution before this, and it was really, yeah, not ideal, and we really needed to get away from legacy networking. So that's why we did that with a one-off. Yeah, that's it. And then we have a different API or API reader. The Nginx is configured by a component which reads the cluster API, the Kubernetes API to get all the services that it can target and configure as upstreams.
Awesome. So you're in your situation, I think you already kind of touched on this. So each service lives in a single cluster, and you just need a way to access services in remote clusters from a source.
Yeah, but the services are similar between each cluster. So but we can target specific services because we need to reach a specific backend actually. So you could look at the U bridge as being connected to one of the backends, and we need to point to the correct one.
Okay. And a backend in this case that is just a per cluster service, or is it like a specific pod?
It is actually a specific pod, but in the first place we are redirecting to the correct service, and then the service itself is responsible for targeting the correct pod.
Okay.
So we did not have, well, first of all, we didn't know about, we didn't know about the pod IP, that you could actually use pod IPs from different clusters. So if you need to align the CIDR ranges and make sure that it all works correctly, and we didn't know that. So we didn't intend on targeting specific pods from other clusters yet. But it would be possible, and I was actually investigating already whether we can build this whole thing with Envoy to have one cluster per pod actually, which you can target via load balancing subsets, and then do that load balancing based on metadata, which we assign in HTTP filter with some WebAssembly. So that's a completely different approach, but it requires that your pods are routable, which is not yet the case. And that would actually remove about 60% of all the complexity in our clusters. So it would actually make the whole thing way simpler.
So, and I guess another approach is with multi-cluster services, I don't know if you've had a chance to take a look at the KEP yet and see how it works for you.
KEP?
Yeah, I'll link it in chat. But it sounds like what you're really looking for is kind of like a multi-cluster headless service, where you actually get a name for each pod. Is that true, or am I?
Kinda. There were about 500 pods of these backend services. Would be quite a long list for DNS. Well, still possible, of course. I think the most lean approach would be to first route it to the correct cluster and then route it to the correct pod in the cluster, because the traffic is KEP. Okay, KEPs. Take a look.
So one option that comes out of that KEP is that you basically an implementation would create a headless service for you that would just let you address each pod directly from each cluster.
Yeah.
But I'm curious if you could take a look, since that's a direction we've been thinking, heavily on, and let us know how it fits your model, and just as importantly, how it doesn't, and what it's missing, and what may or may not work for you.
So what specifically would this service, so it's a headless service, what would it offer other than that you have a whole list of that? Because I think a headless service, you still need to do the load balancing yourself, of course.
Well, okay, so maybe I'm not quite following. So when you talk to a remote service, are you, eventually it ends up at a specific pod, that connection, but do you care which one it goes to in particular, or do you just let it get load balanced?
Currently it's load balanced because it's targeting a service which itself determines the pod of a different service, basically. So there's a layer in between. We have within a cluster, actually, which is maybe not ideal and we want to remove it, which is part of the 60% I said is complexity, which we want to remove, is Redis. So we have a pod which receives an HTTP request, it stores it in a queue, it sends a publish to a topic for, because it knows which pod is connected to that bridge, or the other way around, which bridge is connected to the pod. That's a lookup list, which can be millions lines long. So then you publish only to one specific pod, which serves a certain K of bridges. So then the message routes to a queue, which the pod knows to empty, and it gets sent to the bridge.
Got it. Okay.
So because
I misunderstood then. I don't think a headless service would be the right answer there. I think you,
no.
but this KEP, the API proposed here, could help you just basically create that first link to that routing service.
Yeah. The whole point of the complexity in our system is that you have a dedicated or a specific WebSocket, a persistent WebSocket connection to the bridge. You need to reach that connection somehow, and there are too many clients and too many pods to manage that from every cluster. Basically, it would be much more lenient to first send it to the correct cluster, and then, because also those clusters would not be neighbors, they would be in different regions. So right. it's mostly to reduce the latency in the general case, but then you have the cases where partners of you are in a specific zone. So if they are always in US East 1, then you always need to proxy to a different cluster. That's disadvantageous, but we cannot prevent that. Ideally, the cloud function is of a partner is close to the partner, the bridge itself. Yeah.
Okay. Cool. Yeah, I'd really love your input on that API proposed there, and if that can basically make your life easier, and especially where it hurts, what's not working, what could be added.
Yep, I'll take a look. Yeah, cool. Thanks.
Thanks for the demo, Herman.
Awesome. Yeah.
Yep.
It's for the info.
And for
inconvenient custom build solution. Yeah.
It's interesting to see from my perspective, because I, like you, Herman, also built sort of a bespoke solution, also called Service Sync for that matter. And it's interesting to see another take on it for sure.
Cool. Yeah.
All right. Well, I'll look forward to hearing, Herman, what you and your team's thoughts are about the KEP, and whether, what you might view your robot that you've built, how you might view that relating to the KEP. If we're talked through on that one, I think the next one on the agenda is Chojin. You had the Work API KEP on the agenda. Do you want to talk about that?
Yeah, can you hear me?
Yep.
Cool. Let's see if I can share my screen. Okay, yeah.
Crystal clear.
Nice. So, yeah, so for some background, this idea is originally generated by Valerie by blog post, and we did some prototype on that. The simple idea is like we want to have an API to define a set of the resources or manifests that can be applied to one or multiple remote clusters. So based on that idea, we have a doc to define what the API should be like and the use cases. So in this doc, we basically have some terminologies like in this scenario, you would have a hub cluster that where you will create the work APIs, and then the manifests defined in the API will be applied in the multiple clusters. And there's another terminology like managed cluster. We call that managed cluster in this doc, but there's also some alternative terminologies like spoke and spoke clusters. I think we might need agreement on these terminologies in the future. And also to make this happen, we'll have a controller that consume the work APIs and to apply the resources defining the work APIs to the remote clusters or to the managed clusters. So we concentrate on a very simple use case, like when we define a work APIs on the hub, then there will be a work controller. The work controller could be in the hub or could be in the managed cluster as an agent that consume the work APIs and apply the resources onto the managed cluster. So there are some discussions about whether a push and pull model should be used in a multi-cluster context. Like in the push model, there are some limitations, including how the security, there will be more exposures on the API servers of managed clusters. But to remedy the problem, there's also an option to use the pull model that we have an agent on the managed clusters that watch some workload on the hub and then fetch that APIs and apply it on the managed cluster. So, but for the work API itself, I think it doesn't really constrain on the push or pull model. The work controller itself could reside in the managed cluster as agent or reside in the hub cluster that push the manifest to the managed cluster. So I think this is the API that we have been developed in the prototype in the Valerie's repo. That is quite simple. Like in the spec, we only have a list that to define the manifest that is going to be applied onto the managed cluster. In the status, so this is a manifest and it is just a raw extensions to define any type of the kube resources. In the status, we have two types of the conditions. One conditions is the conditions of the work,
And another condition is a condition for each manifest, which is called manifest condition. In the manifest condition, there is a resource identifier to identify which resource that has that condition. The resource identifier will include like the group version kind and resource, namespace and name of the resource. And also it will have the conditions for each manifest. So in the work, I think, so in the current syncing, we are thinking like for each manifest, we record the conditions of the resources for each resources defined in the work API. So this is a simple example that you could have a work defined in the hub that in the manifest you define that I want to apply a config map onto the managed cluster. After that, after the controller has applied the manifests, there will be conditions for each manifest in these examples. In this related examples, you have an identifier that point to this config map, and also with a condition that this thing has been applied on the managed cluster. I think based on the discussion previously with Valerie that we have some edge cases, and I list some known edge cases also in this doc. For example, it is possible that in the resources of the managed cluster that you want to apply, that resource has some immutable field, or the field has been set by the API server or some defaulting functions. And the work controller may not know whether it need to revert that field or need to update or need not to update that field. And also there are some cases like some automations like HPA controller will try to scale up the replicas of the deployment. But in that case, you may not want the work controller to change the replica back. So this is some edge cases that we are thinking of, and there are some possible solutions. For example, you need a server apply to check whether this is a certain field in the resource has been changed by a kubectl or by a automation controller. Anyway, so this is very simple. I think it is a very simple doc at the first starting point. So I would like to know if the guys could have some comments and suggestions for this doc. Yeah, I think that's all for me.
I saw a question, I think it was from Andrew in the chat about how does this differ from SIG apps application CRD? Chojin, do you want to talk about that?
So I haven't seen read about this application CRD, but to my knowledge, that just to define a label to say what type of the resources that belong to a certain application. So yeah,
I think that's similar to my own impression, which is that I think last time I looked at it, app CRD was really about expressing a grouping or relationship, but not about carrying information about the manifest content or anything about whether the manifest or any manifest had been applied and what state it was in. So I guess my own version of that might be in Chojin, like, let me know if you think this characterizes the work API, is that the work API is about the content and what state is the content in on the cluster that's supposed to have it. You think that's accurate representation?
Yeah.
Right. So I guess my question, and what I'm struggling to understand is like, what difference in behavior or what advantage do we get from, I guess, not decomposing that back into its original resources?
I'm not sure exactly what you mean, Andrew.
Right. Oh, no, it's Richard.
Oh, I'm sorry.
No worries. I guess, like, whereas we could, again, I might be misunderstanding this, but what I understand is that the manifests of the, the deployment and the, services and config maps would be wrapped up into one big CRD or one big resource definition. I guess, what is the difference in working model when all the manifests are packed up into one versus if they're decomposed and just semantically linked via something like the application CRD?
Yeah. Okay. So I think the work what you define is like a content, a list of the content that you don't apply on this cluster, on this cluster, but on another remote cluster. So
I see.
Yeah.
It sounds like there was an aha there. Is it worth surfacing that into the meeting?
I guess the comparison there would be, it's more similar to a Helm chart rather than a manifest. If we were to draw a tenuous link, it's more of like a wrapper on, a set of resources. Is that true?
I think that rings true for me. How about you, Chojin?
Yes, I think that to some extent, yeah, it's similar as a Helm that you have a set of the content that you want to deliver to some other clusters.
Right, because I guess to maybe add some color to my question is, we are also looking at, these manifests as artifacts, right, deployable artifacts, and right now we primarily capitalize on the fact that a Helm chart is just, a tar, right, and so we push and pull these tars from into our repositories during our build processes and our deployment processes. And I guess this would replace that deployable artifacts when we're talking about sort of defining which cluster this workload would belong in, or multiple for that matter. Is that kind of true?
Could you just repeat the last part? I'm not sure I followed it.
Right, so I guess with our current model, it's the Helm chart being pushed and pulled as a deployable artifact, and in this case, it would be the work resource definition that would be traded to or from the managed clusters, if you will.
Yeah.
So I think if I'm hearing you correctly, I'm hearing just contextualizing the work API as like a unit of distribution of a collection of things that are supposed to go together. And I I think it's not dissimilar in concept to a Helm chart in the sense that a Helm chart is a collection of things, right? What I think we should be clear about is that none of the people that I think have like worked together in this group around work APIs so far like have intended to replace Helm charts or necessarily compete with them. I kind of view this personally as like as you could distribute any level of thing this way. I think there's, so for example, when I say any level of thing, I mean at any level of detail. Like you could absolutely pack WordPress into a work API if you wanted. You could also distribute a resource that was like, I want there to be a WordPress, like say there's a WordPress operator running somewhere and it's sensitive to like a WordPress CRD. You could distribute a WordPress CRD, like operator type CR in a work API. So it's not intended to compete at any particular level of packaging, in my own mind at least. It's just about distributing collections of things and accounting for their status as far as whether they've been applied or not. How about you, Chojin?
Yeah, I agree with you.
We had a good question, I think, from Hector, which is, and I don't know if it's really been addressed here yet, but we're talking about how would you ensure an agent running on a specific cluster from watching resources that do not belong to it? So is there like a concept of targeting specific clusters, or how is it actually disseminated?
So I think currently, so the work itself is a namespace scope resource, and the agent running on a specific cluster need to have a certain permissions to watch that the work APIs in that namespace to get the work. So we haven't put the cluster concept in the work because I think maybe we could have them separately. For example, we could have different namespace for different clusters, and each agent watch on a different namespace on the hub, so they could only watch the resource that has been put on a certain namespace. Okay,
I think that makes sense. I like scoping at namespace. I think that's pretty consistent with other things we've talked about. Like if a cluster has a namespace and another cluster has a namespace, they should both have access to the same things, right? For that namespace. That's kind of where we've been going. But that goes to another question I had, which is, so the manifest then, is there an expectation that every manifest or every bit of work every bit of work in a manifest, should it all belong to the same namespace then? Is that how you're thinking about this?
No, I think that it's just to define the things that need to apply it on the managed cluster. It could be, so in the manifest, it could be something cluster scope resource and some namespace scope resource from different namespace. For example, you could have a CRD and for example, operators and CRs defining in the namespace, in the manifests. Yeah.
I think there might be a mismatch. So I understood that Chojin, that you were referring to the namespace within the hub as a container of works that were scoped to a cluster.
Yeah. Yes.
Jeremy, did you have the same impression?
I'm sorry. I'm trying to to map my mental model here. So a namespace in this to the work API then maps to a cluster, but not to a namespace. Is that what I'm hearing? Like each cluster would have its own work namespace?
It could, so it doesn't map to a namespace on the managed cluster. So it just map to a, for example, a cluster defined in a hub. That agent could watch a certain namespace and get manifest from there.
Okay, so could I have multiple clusters watching the same, multiple managed clusters watching the same namespace for their work?
I think we could, right? So I think if multiple cluster have some shared work that they want to, so if multiple clusters all want the same work manifest to be applied, it could watch the namespace. It just all the agent on these clusters need to have the same RBAC on the hub.
Well, the status that's in there currently is about the status within a single cluster.
Yeah.
And this is sort of like one area where I think Valerie and Shojin have tried to kind of work backwards from the like interface between this API and a single cluster, but without trying to characterize something like cluster registration, or having to address a particular cluster in the API surface. So a next step that I personally anticipate here is working further backward to how would you schedule things into a single cluster, and how would you schedule the same work into multiple clusters, if that makes sense, where that could easily be like a different API surface from this exact one. But my own impression is that the one that is in the proposal today is about the interface between a hub and a single cluster where work is applied, if that makes sense.
That does. As a follow-up, and probably worth thinking about, and maybe it just needs more digging into, but I'm very curious about what that work namespace relationship is to the namespace of the manifests themselves. Like, is the expectation that a cluster has permission to watch namespaces foo and bar, but the work contained in those namespaces is entirely unrelated to those? How does that kind of map in an intuitive way? And like, what if a cluster doesn't actually have namespace bar, and you can't run anything in bar, but it watches work sent to bar and it deploys that work in foo? Like, it creates this kind of second layer of namespace matching that I think you'd need some kind of mapping between.
Yeah, I think there's probably a lot of different scenarios to talk about of that type. So for example, it's possible for me to imagine maybe that you have multiple agents watching particular namespaces within a cluster that's under management by the work API, and maybe those individual agents have permissions that are partitioned by namespace in the most extreme, where maybe they can only write into the namespace that they're deployed in, but maybe they have different degrees of permission, versus maybe you only run one agent per cluster. It seems like the kind of thing that there might be differences in how different human operators might want to characterize their like deployment topologies, right? Like push versus pull, single agent pulling, multiple agents pulling, et cetera, et cetera. It seems like there would be an opportunity to implement some of those semantics as like admission constraints on the content that you could put into a work of a particular namespace. Lots of details to think about.
Yeah, and I don't know that these things necessarily need to be prescribed by an API either, but I think it would be helpful to kind of add to this doc, like basically what that namespace mapping permission kind of looks like at a high level.
Okay.
Yeah, I have another question. How, if you are handling row manifest, how will you handle situations where you have overrides of certain resources? And I mean, are you going to have the whole manifest just changing, for instance, a property value? How will that will work?
So I think the question is if there is some other actors that change the resources that being applied by the work, how would the controller, work controller revert it? Is that the correct question?
No. It's more or less similar to what you can have now with QFed, that you have overrides. So you can define overrides of property values for a specific cluster. So you share the same resource and you just say, I want to just change the image tag of the deployment or something like that. But I only want to change it for a cluster name A, or in this case, right?
Oh.
So I'm just wondering right now, in this model, you're having row manifest. So it sounds to me a bit more complex in the meaning of how you can handle these scenarios right now. Is that correct, or how this scenario could be handled, or probably it's not in the scope? That's the asking.
Okay, so the question is about the override. So I think that in the KubeFed there is some API. There is APIs that you can define some. You can define that in one cluster could override some field in deployment, and in another cluster override to another value. I think. Yeah, I think that currently this API hasn't considered about the override across different cluster. The first design is about just to distribute the workload to a single remote managed cluster. It doesn't actually haven't relate to any clusters, and haven't considered about how to map to different clusters. So, but I think it is possible that we could build another layer on that have the override to use the work, finally distribute the workload. Does that make sense?
Oh yeah, I will have another look, probably commented in the document. So thank you.
Thank you.
Yeah, I'm +1 at making substitution parameter type stuff something that happens at a higher layer, and focusing at the layer described here on just the most essential parts of is what in here, what got applied, and what status does that have. But agree, that seems like a natural, like overriding parts of this seem like they're at like a layer above when it comes to scheduling, maybe, since those two were strongly linked in KubeFed, right? Scheduling and overrides, Hector.
Yeah, you're right. Yeah, I mean there's completely different scopes. Yeah.
Yeah.
Thanks, guys.
So Chojin, for next steps, it might be worth kind of having a discussion in the SIG about like what use cases matter to people around scheduling, what use cases matter around around substitution to, and then also I think it would be interesting to dive into some of the edge cases and what kind of mitigations we see for them.
Okay. Sure.
Okay, it sounds like we might be talked through for now, unless someone was getting ready to say something. If so, go ahead. All right. Well, thanks everybody for joining us today. Thanks to Herman and Chojin for presenting. Appreciate it. We'll see you next week.
Yeah, thanks a lot.
And thanks, Jeremy, for starting the meeting.
Thank you.
Sorry,
All
my
right.
sound
Take
wasn't
care,
working.
everybody.
See ya.
Thanks, everyone.